Okay, so today we're going to talk about rational functions, okay? Rational functions. So basically, we're going to be graphing these weird fractions, okay? Anytime you have a division problem and you have the possibility of dividing by 0, you're going to have some problems, and we're going to have some problems. So if I first of all look at example 1.
You can cancel it.
We can cancel it. So I already know this. If I can cancel the x minus 2, then I know that x, which is not supposed to be 2, right? That I know that there's a hole at 2, okay? Because if I can cancel out the problem, and x can't be 2 because 2 minus 2 is 0, I already know because it's removable that there is a hole at 2 something. We'll put question mark because it doesn't have corresponding y value, right? 2 question mark. Because if it's a hole, it doesn't exist. So we'll put 2 question mark, okay? And we'll try and graph in about where it is with the calculator, okay? Second thing I see is x cannot equal -3. But I can't get rid of -3. -3 is non-removable, which means it's going to stay and it's going to kick my asymptote, okay? So I already know that there's going to be an asymptote at x equals -3. So first of all, I'm going to just do that. I'm going to go and graph in at 1, 2, 3. I'm going to put in my asymptote. The calculator doesn't always graph the asymptote because it's an imaginary border line. So the calculator doesn't always graph it. Some of these calculators will put it in, some won't. It's not part of the graph. It's a boundary line, okay? Now, if I kind of want to see what it looks like, I may as well just graph it. So but if I graph it, got to be careful. I'm going to put parentheses here and here. See what I'm doing? And parentheses here and here, so that I have the entire top divided by the entire bottom. So when I put in my calculator, and I'm going to go, all right, y equals, clear that one. I'm going to go, oh man, let me grab a different calculator. Hold on, is there one left?
No.
No.
This is what I got.
Okay, all right, you and I'll share. Okay, perfect. All right.
Is that right though?
Almost. So I want to graph the original. Okay, I want to graph the original, so I'm going to go double parentheses, x plus 1, parentheses, x subtract 2, parentheses, divided by, parentheses, I need double parentheses, I'll tell you why in a second, x subtract 2, parentheses, x plus 3, parentheses. So the reason I need the double parentheses, Will, is I want to make sure that all of this is divided by all of this, right? If I don't use the double parentheses, then all I'll get is x minus 2 divided by x minus 2. That's all I'll get, okay? Which makes it a different problem, isn't it, okay? Thanks, Felicity. So if I graph this, check my window. That's a good window. Okay, it looks like this, okay? Now, one of those things I already know, okay? Okay. So one of these things I already knew, and I already knew that, right off the bat, I already knew there had to be an asymptote at -3, right? And there it is. There's my -3. I also know there's a hole at 2. So if I go to trace, and go to -3. No, not -3. That's my undefined there. Sorry, hole at 2. Trace 2. Sure enough, there's no y value, right? So I know there's got to be a hole there. So now if I'm going to graph this, let's take a look at the picture on the calculator, and let's graph it. So I'm going to graph it. I do know it goes like this, all right? From my calculator, and it goes like this from my calculator also, okay? Now, there's one more thing it has, which I'm going to talk about briefly today, but I'll talk about it more tomorrow, and that is a horizontal asymptote. And I'll explain how to get a horizontal asymptote later, but there is a horizontal asymptote there, okay? So if I take a look at the graph, it kind of levels off. See how it kind of levels off? See how it levels off? So it's leveling off at 1. It's leveling off at 1. That's my horizontal asymptote. Okay, now, I also have a hole. I have a hole at 2, so I'm actually going to go to 1, 2, and I'm going to put a little hole right there, okay? Now, the hole you can't see. The hole is technically this wide, right? But what we're going to do is we're going to put it in there so we know where it's at, right? So I just drew a little hole there saying, hey, Mr. Davies, there's a hole there. Even though you can't see it, there's a hole there, okay? All right, now, let's keep moving on. So in example 2, let's graph first just 1 over x, okay? So I already know there has to be x cannot equal 0, because if I put 0 in here, 1 minus 0 is 0. So right off the bat I have a vertical asymptote at 0. I'm also going to have a horizontal asymptote at 0. Again, you don't know how I'm getting these yet, but I'm going to explain that in a bit, okay? So now, let's put my calculator, right? Why not just see it? Okay, y equals clear 1 divided by x. I'm going to change my window slightly so we can see a little bit better. Okay, I'm going to go from -3 to 3 just so I see a little bit better of it. I'm going to make it smaller so we can see a lot of it. Okay, change my window. -3 to 3, -3 to 3. Y equals 1 over x. Let's graph it, okay? Alright, now that kind of concurs. You can kind of see where there'd be a vertical asymptote, right? It's taken off towards an asymptote. So you can see asymptotes where it's going to be going towards 0 here at an asymptote's there, okay? So let's just graph this in. So the graph looks something like this. And like this. Now it doesn't touch your asymptotes. It approaches them, gets closer and closer as you go to infinity, but it's just boundary lines. Okay, now that's what we call our parent function. So our standard 1 over x, that's our standard graph. That's our parent function. Now what we want to do is move it, manipulate it, and change it around. Okay, so now if I take a look at example 3, the only difference is it's almost 1 over x, but it's 1 over x plus 2. So we learned before that if it's on the inside, we move it back and forth, but the opposite direction, right? So on the inside, we move it horizontally, but the opposite direction. So I'm going to take and move the graph back 2 because of this 2 right there. So let me take my parent function. I'm going to move the entire thing back 2, okay? I'm recording you guys. You have to wait, okay? So if I take the whole thing back 2, let's just move the crosshairs of the asymptote. We'll just take the asymptotes, go back 1, 2, we'll graph it in, okay? So I'm going to take my asymptotes and move it back 2. So I took my asymptotes, moved it back 2, and let's just graph it in. So this picture is now here. I just moved it back 2. So my picture is here and here, all right? Okay, example 4, and of course, yes, you can put it in the calculator and double check it, but it's just easier to move it, right? Example 4, we're going to do 2 things. We're going to move it forward 3 or to the right 3 because it's going to be the opposite of the inside, and we're going to move it up 2 because of the positive 2. So what we're going to do is just take the asymptotes, the crosshair of the asymptotes, just move it 3, 2, and then put it in my graph, okay? So I'm going to take my asymptotes, this asymptotes here, go over 1, 2, 3, up 1, 2. So I just move the asymptotes, and then what I can do is just put my graph in. So my graph's going to look like this and like this. All right. Okay, real quick, before I flip the page, what's the domain of this graph? What's the domain of this graph?
What does that mean again?
All real numbers, except what? What can't x be?
0.
Right, but what x value would make it 0? -2, right? So x cannot be -2, okay? Domain. Because we're going to talk about it later, okay? Domain. So in this graph, what's the domain? All real numbers, except what can x not equal to? Positive 3. Good. Because 3 minus 3 makes 0. Okay, good. And you can even see it doesn't exist. 3 does not exist, right? Okay, ready to turn the page?
Oh, there's too many on that.
All right. Example 5. Now, we could go straight to graphing it, but before we graph it, I want to go ahead and factor some things and see what happens. So right off the bat, let's factor, okay? So let me rewrite this as x minus 3, x plus 1 over an x minus 2, okay? Just factor it. So first question is, x, what can x not be? Okay, x cannot be 2. Can you get rid of it? Can you get rid of it? Can you cancel it out? So if you can't cancel it out, it's an asymptote, okay? So we know what x at 2 is an asymptote, a vertical asymptote. So before I even put this in my calculator, I already know that I'm going to go to 2 and go boom, 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 boom. Okay? Now, I also know where the zeros are. 0 on the top is 0. 0 on the top is always 0. So what values here will make this thing 0? What about here? What would make it 3? Because 3 minus 3 is 0, right? So I'll have a 0 at 3, 0, and at -1. So I can also graph that. I can put a dot at -1. And 1, 2, 3, I can put a dot here at 3. So before I even touch my calculator, I already know some basic things. I also know the y-intercept. You know what? The y-intercept is going to be at 3/2. If x is 0, now think about it. If x is 0, what do you wind up with? If x is 0, what do you wind up with? Don't you? If x is 0, think about it. If x is 0, what do you wind up with? 3/2. So I'll have a y-intercept right there. Okay, now let's go ahead and put it in our calculator and find out what it looks like. Okay, so all right, I can do that. Quit. Go y equals clear. I got the wrong one. I got the one I don't want. Here we go. Okay, I'll give it back to you. I promise. Y equals clear that. So let's put in our, and I need parentheses. Will, you with me on parentheses? Got to have parentheses, okay? Because I need the entire top divided by the entire bottom. So I'll go parentheses, I'll go x squared minus 2x, subtract 3, parentheses divided by parentheses, x, subtract 2, parentheses. Let me get my window to look better. Okay, there we go. Okay, it looks like that. So there's a few things that don't surprise me. Okay, first of all is the asymptote. I already knew where the asymptote was, right? So it's in there. Second thing that didn't surprise me is the zeros. It goes through at 3. It goes through at -1. I knew that, right? And it actually goes through at 3/2, doesn't it? 1 and 1/2. All of that I knew. So then all I got to do is just graph it in. Now remember, we're going to approach. So as I get closer to the asymptote, what happens? What happens here? It curves and gets close to it but never touches it, right? And the same thing here, as I'm coming through from here, it gets closer to the asymptote. What happens? It curves and gets closer to it but never touches it. Okay? Last example. Okay? So again, factor. Okay, let's factor. So I'll have an x plus 2, x plus 3 over an x plus 2, x minus 3, or x minus 2, sorry, my bad. X plus 2, x plus 3 over x plus 2, x minus 2. Everybody agree with my factoring? Okay, everybody good? Okay, so what can x not be? X cannot be what?
2.
And perfect. Okay, that's right. Now, my whole is at x equals -2.
And can it not be negative?
It's okay. 0 on the top, you ready? 0 on the top is okay. Great question. 0 on the top is okay. 0 on the top is just 0. And 0 is a number, right? 0 on the bottom, can't do. It's not a number. Great question. Take a look at the fraction. Will, what do you see that I could cancel? Yeah, I can cancel the 2's. And so if I cancel the 2's, then I remove the problem. And if the problem is removable, it's a whole, okay? But I can't get rid of this one, can I? So then I know I've got my vertical asymptote. My vertical asymptote at x equals 2. So let me go ahead and put that in for sure, okay? So, all right, 1, 2. So I'm going to put my vertical asymptote there, okay? Becca, let's talk about zeros. It's going to have a 0 at -2, but I can't graph it because it doesn't exist, right? But it does have a 0 at -3. Okay, does that make sense? I'm not going to put down the -2 to a 0 because that's a whole, right? So don't put that down, that doesn't exist, okay? So now there's one more thing, and that's my horizontal asymptote. Okay, here I'm going to show you how a horizontal asymptote is found, okay? So when you do your horizontal asymptote, you go to the biggest divided by the biggest, okay? So what's x squared horizontal? Horizontal. X squared over x squared. What's that equal? It does equal 1. So I'm going to have a horizontal asymptote at 1. That's how you get the horizontal asymptote. It's biggest divided by biggest. Some things don't have a horizontal asymptote, like this one didn't have one, right? They don't always have one. This one does. If it's the same over the same, you'll get a number, okay? So let's see what this looks like, okay? I know a few things about it already. Let's go ahead and graph it. Clear. I'm going to go parentheses. I'm going to go x squared plus 5x plus 6 parentheses divided by parentheses x squared, subtract 4 parentheses, and let's graph it, okay? Alright, no surprises. I mean, it looks exactly like I thought it would be. The asymptote's exactly where I thought it was going to be at 2. Now, I said there was a hole at 2, right? Or at negative 2. So if I go trace negative 2, what's my y value? There's no y value. So at negative 2, I have a hole. And it's right about here. Negative, oh, I put that in the wrong spot. That's a hole. There we go. Wrong spot. And so I can just go ahead and graph it in now. It goes something like this. And it's going to go through at negative 3/2. I know that. There's my hole. I'm making a hole a little bit bigger. This actual hole is right there. And then the other part of my graph goes like this, okay? Now, do you see the horizontal asymptote? Look at it on the calculator. So as the calculator cruises along, it levels off, doesn't it? And it's going to level off at a height of 1. As it cruises along, it's going to level off at a height of 1. And that's what your horizontal asymptote does, okay? All right. It would be good if we worked on this together, right?